All right, so last week we talked about expanding and condensing logarithm forms, but we're going to play with those a little bit more. So on 35 to 42, that's mainly where we're going to work. But there's a couple rules, a couple special rules. One of them is used often, the other one not really, but there's two special cases, which I'm going to go over in questions 33 and 34. So let's take a look at question 33. The special case is when the number here as the base and the number here happens to be the exact same number. So in this case, log base 7 of 7. Okay, so that happens. So let's take a look. Let's say this is equal to x. I don't know what it is right now. So based on this, because the base is 7 and this is equal to x, let me write this as 7 to the x equals, and then I'm going to use this number, 7. So 7 to the x is equal to 7. Now the 7 on the right side, that's technically 7 to the 1, right? 7 to the 1 is 7, so I can write it as an exponent. Now the base is the same. So I'm going to say, in this case, x is equal to 1. The rule says that when the base and the number there are the exact same thing, this is going to equal to 1. So what do I mean with that? Let's say I had log base of 3 of 3. I'm just going to say that's equal to 1. What if I had log base of 2 of 2, log base 2 of 2? That is equal to 1, right? This rule is used often. When the base and the number there are the exact same thing, this is equal to 1, okay? So expect to use that today as well, that it is used often. Now the other one is here, log base 7 of 1, okay? The interesting part here is the 1, right? So this is going to happen sometimes. So for right now, let's just say this is equal to x, because I don't know what it is. So I can write this as 7 to the x is equal to 1. Now, I wish I could write 1 as 7 to the something. And actually, I can, right? Let me write the left side as 7 to the x. And like I said, the 1, I wish I could write it as 7 to something. I wish I could write this as the base 7. Now, we learn a rule in exponents. Anything to the 0 power, so 7 to the 0, it's equal to 1. So I can write this. So here, since the bases are equal to each other, I'm just going to say x is equal to 0. So based on this rule, if I had log base 3 of 1, I'm just going to say that's equal to 0. If I had log base 5 of 1, I'm just going to say that's equal to 0, right? The basis it's not important, but when it is of 1, this thing is going to equal to 0. Again, it's a special rule, so not used that as often as the one that we saw in number 33, but it is used. Now let's take a look. Use the properties of logarithm and the logarithms provided to rewrite each logarithm in terms of the variables given. So we learn how to expand and condense. We learned that multiplication expands as addition, right? The multiplication inside a log, it expands addition of 2 logs. And then we learned that division in a log expands as the minus of 2 logs. Okay, so here, I'm just going to say it, all right, using the numbers, all of this are going to be log base 6, if you notice. Using my numbers, 9, 4, and 10, I wish I can come up with, multiplication or division. Using these numbers, I wish I can come out with 800. That's the one that I want to begin with. Sometimes I might use a special case, log base 6 of 6 is equal to 1. I might use that. So in this case, I can also use 6. So again, I'm looking for combinations used in multiplication or division using the numbers 9, 4, 10, and 6. I need to have them equal to 100. Now, some of you guys might be like, yeah, I can do that as 10 squared or 10 times 10, which is the same thing. So let me write this. Let me rewrite log base 6 of 100. Let me let this equal to log base 6 of 10 squared. Now we learn that when there's an exponent, I just bring it to the front. So this is going to be equal to 2 log base 6 of 10. And I know the log base 6 of 10, I'm going to say that is equal to t. So I'm just going to write this as 2t. That's going to be my answer. Don't forget to capitalize the t. I want you guys to be able to use this. We're going to play with these formulas because I want to make sure you guys know how to expand and condense logarithms. Okay, so let's take a look at number 36. Don't forget that we always have the special case. So let me just write log base 3 of 3 is equal to 1. So I'm going to do log base 3 on all of here. And I need to finish with 3 over 10, all right? 3 divided by 10. So I'm going to use this log and this log. So let me rewrite this. So I'm going to say this is equal to log base 3 of 3 minus log base 3 of 10. Remember, a division in a log can be separated as a subtraction of 2 logs. So I did log base 3 of 3 minus log base 3 of 10. Okay, now log base 3 of 3, let me just call that 1 minus log base 3 of 10, let me just call that v. So my answer will be 1 minus v. All right, let's take a look at number 37. If I need to, I know there's a special case, log base 5 of 5, it's equal to 1, right? If I need to, I might use that. Now, I need to find log base of 5 of 3 over 2. But I don't see a 3 and I don't see a 2. Now, let me rewrite my fraction. I know 3 over 2. When we think of fractions, 3 over 2. Let me just focus on the fraction. Can I possibly write that as 6 over 4? I can also write that as 9 over 6. Right? I can unsimplify a fraction. Right? Isn't that the same thing? 3 over 2, 6 over 4, 9 over 6. Now, reality, I'm going to use my 6 over 4. So to begin with, I have log base 5 of 6 over 4. You guys are going to see in a minute why I'm using 6 over 4. Some of you might already see it. Okay, now a division in a log can be split as a minus of 2 logs, right? That's a subtraction of 2 logs. So this is going to split as log base 5 of 6 minus log base 5 of 4. Now, log base 5 of 6, I see it right here. Let me replace that as x minus log base 5 of 4. I see it here. Let me call that z. So x minus z. All together, no spaces, all together, capital letters. So x minus z. Like I said, no spaces. Make sure you don't include extra spaces in there. Now here, log base 9 of 84. There's a special rule, right? I can always use log base 9 of 9 is equal to 1, right? I can always use that. Now I'm thinking, all right, which two numbers either multiplied or divided might equal 84? Now division couldn't quite work, but I'm looking at, I know 7 times 12 is 84. So my focus is going to be on these two logs. Let me break this as log base 9. Now in here, inside my parentheses, I'm going to put parentheses. Inside of my parentheses, let me go 12 times 7. Now 12 times 7 is 84, right? So I change that as 12 times 7. Now multiplication in a log. Don't we split that as addition of two logs? So let me replace this as log base 9 of 12 plus log base 9 of 7. Now log base 9 of 12, let me replace that with a y plus log base 9 of 7, let me replace that with a c. So my answer would be y plus c. Again, I want you to practice on expanding and condensing logarithms. Let's take a look at number 39. Now 3 over 2, I don't see a 3, I don't see a 2 here. Now, there's always a special case here, right? There's a special case here that we're not seeing. Log of 10, I'm going to say it's equal to 1. Now, some of you might be like, why 10? Where did the 10 come from? When we don't see the base, we just see log. We don't see a base. The base is always 10. And I mentioned that when we talked about logs last week. When we don't see the log, the base is 10. So all of these are log base 10. Log base 10 of 8 is going to be A. Log base 10 of 7 is B, and so on. Okay, now 3 over 2. So let me just take a look at my fraction, 3 over 2. Another way I can write a 3 over 2, I can write that as 6 over 4. That one I'm not going to be able to use. I don't see a 6 or 4 in there. Another way I can write this is 9 over 6. Another way I could write this fraction is 12 over 8. Now that one I think I can use. I can see the 12 and I can see the 8. So let me rewrite this as log of 12 over 8. Right, because I simplify my fraction. So let me write this as log of 12. Now let me have you think. Log 12 over 8, right? Division. Do I go up plus or minus in this case? Gotta remember, 12 over 8 is basically 12 divided by 8. Okay, so log of 12 minus log of 8, right? We do minus. Now, log of 12, let me replace that as a c minus log of 8, let me replace that as an a. So my answer will be c minus a. Now, 88. Looking at the numbers given, can I multiply them, divide them to come out with 88? Remember, you still have log base 7 of 7 is equal to 1. You have that one there. You can always use it as well. But let me rewrite this. Log base 7 of 8 times 11. Right? 8 times 11 is 88. Now I can expand this as log base 7 of 8 plus log base 7 of 11. Now log base 7 of 8, let me call that u. Log base 7 of 11, let me call that w. So I have U plus W. Okay, so two more examples here. Remember, we always have the special case log base 7 of 7. Let me write this as log base 7 of 7. We know it's equal to 1, just in case I need it. Now I need 1 over 100. Okay, I see log base 7 of 10. So I see how that 10 can be used. Now, interesting though is that I know 10 squared is equal to 100. But now here my fraction is 1 over 100. Okay, so two ways how we can do this. Another one that we have is, another special case that we have is log base 7 of 1 is equal to 0, right? We have that. Okay, so I can go here. Let me break this as log base 7 of 1 minus log base 7 of 100. Log base 7 of 1, let me just call that, or let me write this as log base 7 of 1 minus log base 7 of 10 squared. I see exponents, right? 10 squared. So let me rewrite this as log base 7 of 1 minus 2 log base 7 of 10. Remember the exponents, we just bring it to the front. Now let me rewrite this as log base 7 of 1 is 0 minus 2r. Right, log base 7 of 10, it says r. 0 minus 2r is just going to be known as negative 2r. Okay, so now I said we have two ways how to do this. This is one of them. Let me show you a different way how we could have done this. I could have said, I look at this as log base 7 of 10 to the negative 2 to begin with. I know 10 squared is 100, 10 to the negative 2, right? When I use a negative exponent, doesn't that flip my fraction? So I could have seen this as negative 2 log base 7 of 10, which is just negative 2r. Nice, right? We could have done it two different ways. Okay, let's take a look at number 42. I don't think I need a special case because I see 63. Actually, I do. I do one special case. Log base 7 of 7. I know that's equal to 1. Now, let me have you think. To help you a little, I'm going to use this too. Okay, so I'm finding log base 7 of 63. And I'm going to use the two that I highlighted. Okay, so let me write this as log base 7 of 9 times 7. Right? Isn't 9 times 7 63? So now I can break this. I can split this as log base 7 of 9 plus log base 7 of 7. Log base 7 of 9, let me call this C, plus log base 7 of 7, let me call that 1. So C plus 1. Beautiful. Let me zoom out. Now you guys can see what we did. Don't forget the two special cases.